Before I do example number 1, I just want to do a refresher course. You probably briefly covered this in Algebra 2. A complex number, and I'm just going to write the definition right out of the textbook, okay? A complex number is dealing with a real part and an imaginary number, all right? So it's usually written as a plus bi, and so the real part of the number is the a, and then the bi we would call the imaginary part. And you say, imaginary, what does that mean, Mr. Adams? Well, imaginary is a fancy way to represent the square root of -1. So sometimes we get negatives under the square root, and this really deals with the quadratic equation. So I know that the square root of -1 is something I can't get a real number solution for, because I need to pick a number that when I square it, it equals -1. The problem is anytime you square a number, it will always be a positive value. In other words, if I say -2 squared, that equals 4. If I say +2 squared, it equals 4. So then the square root of 4 is equal to plus or minus 2. The problem is that I can't take anything and square it and make it equal -1, not with real numbers. Because when you square something, when you multiply a negative times a negative, it will always be positive, which is why we can only take positive numbers and find the square root of them, right? You can only take the square root of 0. You can only take the square root of 1 or 2 or 3 or 4 or 5 because they're positive numbers. When you try to take the square root of a negative number like -1, you can't do it. Okay? You just can't do it. So we mathematicians, we love to plug in letters for numbers. We don't know what this number is, but we will call it I. Okay? So when we talk about an imaginary number, the square root of -1 is equal to I. With that being said, if I square both sides, then I squared should equal what? The square root of the square root of -1 squared, which is, when I square a square root, what am I left with? Just the base. So -1 is actually the same as I squared. Does that make sense? So we're going to use this information, and you'll want to get used to that, because that's what we're going to need to do example number, well, everything in this chapter, or this section of the chapter. So remember this, that the square root of -1 is equal to I, and that -1 is equal to I squared. And that'll come up a lot. We're going to use that a lot. So now let's look at example number 1 from our textbook. Example number 1 gives us this big, long, crazy problem, and I'm just going to snap a picture of that. Okay, and now I'm going to write that down. So let's put that on the screen so we could see it. Okay, and let's get that in there. For example number 1, what they're asking us to do is basically add those up or subtract them, and then kind of simplify our expressions or equations that they have listed there. So let me write this down on a piece of paper. So right out of the textbook it says 7 minus 3i plus the quantity 4 plus 5i, and then we need to solve that, and then the next one is b and that's going to be the quantity 2 minus I minus 8 plus 3I. And I'm going to write it a little different than the way the textbook does it. So here are my two problems, okay? So when it comes to adding numbers, I really don't need the parentheses, okay? So I could think of this as 7 plus 3I plus 4 plus 5I. But remember that a complex number is a plus bi. That's the whole number. That is the complex number. It's represented by two parts, the real and imaginary, but those are the two parts. So when I add one complex number, in other words, this is a complex number and this is a complex number, I have to really kind of add all four elements together, right? So when we add that, you really just kind of use basic algebra. You know, we're going to use like terms, right? So 7 is the real part, and 4 is the real part. And then negative 3i is the imaginary part, and positive 5i are the imaginary part. So what I'm really going to do is I'm going to say 7 plus 4, and that represents the real portion of the number. And then I'm going to minus 3i, or add it to 5, or however you want to say that. Okay, and that's going to be the imaginary part. So remember that this whole number here is going to have a real and imaginary part. So this is the real part. And I'm really writing in a lot of detail. You don't have to do your homework with this much detail. But take your notes that way. And this is the imaginary part. And you probably can't see that on the board, but trust me, it says imaginary. So when I add them up, the final answer is 11 plus 2i. Now that's the whole number. 11 plus 2i. Okay? Yes?
Why is there no I after 5?
Because I forgot to write it down. Because I'm trying to talk and teach and all that stuff, and I forgot to write it down. Good question. Any other questions? So now that you've got the hang of this, let's do something different. Now if I have this negative number, what does that mean? It means to subtract, right? But we could also think of that as being like a negative 1. And so if that's a negative 1, normally what we would do is we would distribute that negative 1 through the parentheses. And so Mr. Adams likes to think of it that way. So again, I have 2 as the real part, and then I have 8 as the real part, and then I have my imaginary negative 1i, and then positive 3i. And so what we end up with is we're going to end up with 2 plus negative 8, right? Because I got to distribute that 1 through. And then I have negative I, and then when I multiply the negative 1 times a positive 3i, I have another negative 3i. And so that's my whole imaginary number, where these here are going to be the real numbers, and then this stuff here is all the imaginary portions. But the real plus the imaginary represents the complex number. So my final answer is negative 6 for I. Okay? Any questions on that?